And such a large shortage, and not only are they a shortage now, but a growing trend in a shortage in the future. So it's a good problem to have, right? We've got a lot of business and industry coming in with some of these really high demand and high paying jobs, and so the institutions have to figure out a way to ramp up our production so that our students can qualify and participate in these areas, but that the state economies also wins as well.
As of right now, I'm in the 5th level of our engineering program, which is EDD, and we have to innovate or make a design basically surrounded around any problem that people have each and every day. And my group, our goal is to go green. So right now we're trying to design something that will allow people to reuse rainwater and save a lot of money on their water bills. So our design is, as the rain falls, it falls into this collecting barrel, and we have a filter that filtrates all of the water and directs it into the piping inside of your home so you can use that water instead of the water that you would have to use that you pay for. So we had to make sure that none of our ideas are already used as ideas. We had to find patents. We had to make sure that it would actually work. We had to think about the people as a whole. We had to think about the market that we were going to focus on. So it takes a lot of research. So it's not something you can just come up with and say, oh, we can do this.
I'm doing 3 different examples. I am doing a solar power example with the fuel cell and the solar power car. I'm doing simple machines as well as modulus elasticity. We came up with them by pretty much using what we know and what we've learned, because right now we're doing principles of engineering, which is we're just basically building things, trying to get used to how things work, and to put things together like the simple machine I have behind me. It takes a lot of teamwork, and to put it together, it's really tough.
My project is working with puzzle cube pieces, and it's somewhat of a replica of the Rubik's Cube, and it's really introductory to engineering design and the engineering base for 9th graders, so you can get a feel for it before you go to 10th and 11th and 12th grade. So we're really working on how you can do multiple solutions to the Rubik's Cube.
We're going to be demonstrating our bone detectives, where we take bones like a skull, pelvis, femur, and humerus bone. We measure it to see how old or how tall, how wide the person was, or how tall they could be. From this project, the most useful thing would probably be able to work by myself and also with a group, be able to communicate with the group and talk about different bone lengths and see if we agree on the same term.
The process of coming up with this really has to do with working together and really researching what kind of things are needed to figure out those types of things like age and race for the person. My project involves the forensic anthropology, and it is bone detectives, and it involves researching a missing person that was found in his bones and figuring out who this person actually was.
For my project, I had to design a library from an old warehouse, which we had to add certain rooms in and make sure it all coincided with code. How to actually design a building and then check the beams for the structural strength they'll need to support the building.
I actually represent a class that's purpose is to learn the design and application of circuits that are used in everyday technology, computers and such things like that. As technology grows every day, it's going to be more important for people to know how it works and how to build it and how to design it.
Here we are demonstrating some of our VEX robots, which we have completed in GTT1, and our SNAP circuits, which we have done in GTT Course 2. GTT is a course that you can take in junior high, and it basically goes over the concepts of engineering and also starts with gear ratios, and then we move on to incorporating our gears into things like our robots and our circuits, and those really help prepare us for our future jobs.
I work on Autodesk Inventor, which is a modeling software that you use to create physical objects in industry. I enjoy it, creating physical objects, and because sometimes I can't always get what I want, so I just create it. And if we don't have a 3D printer, but if we do, we can print out these physical objects and use them in our classroom.
We've worked on VEX, Autodesk, Snap circuits, and drawings, like sketches of engineering sketches. They're important because they teach you the basics of engineering and how to properly make an engineering drawing so it's universal and people can understand what you're trying to design.
This is a class, and we are basically introduced to engineering, and we do a lot of hands-on models and programs. We build robots with gears, systems, and we go on to different programs like the Robot C program. Engineering was basically stereotyped for guys, and at first when I was going into it, I thought, oh, it's probably just going to be just me and a bunch of guys. But when I got in, there were a couple girls, and it's just been fun with all the girls.
The most exciting thing I learned about this project is that it's going to take a lot of hard work and dedication, but when you actually come up with that idea and you realize that it's going to work, that's very exciting for me, because that's something you came up with using your mind and your teammates' minds, and when you put all those ideas together, it just comes out to be something extraordinary and amazing. So that's the most exciting part for me.
I've learned that math and science really work well together, and that you need both of them in the engineering field to be successful. It's pretty much the projects, it's an amazing thing to do. It's very fun once you realize how they come together and how they're involved within our daily lives.
The most important thing I've learned is you can solve things with more than one solution, and in order to make it work, you need teamwork and problem-solving skills and good communication skills with your teammates.
From this project, I've really learned a lot of problem solving and figuring things out and working with a team.
It's important because of if we want to go on to a biodetective field, we could know how to do DNA detectives, how we can do bone detectives, we can investigate crime scenes, we could take this into math and any other subject.
This is important because it's actually used every day, and it can help me in college.
It's given me a good basis in electrical engineering, something that I might want to pursue in college. But it allows me to understand how things work that I use every day. I mean, your phone, your computer, light switches, all sorts of just common things.
I've learned many different principles of engineering. I've learned teamwork, working with definitely a lot of different people, certain concepts of engineering like electricals and the gates.
I learned a lot of things like patience, and because some of the commands you do are frustrating because you either get an error or it doesn't work because you may over-constrain or over-dimension. So you learn that you want to limit yourself when you're actually trying to create objects.
I have learned what not to do with the snap circuits from my mistakes, and how to 3D model.
I've learned teamwork. We do everything in teams. I've learned that some combinations work and some don't.
After I graduate, I plan to focus on a major in biomedical engineering, and I'm very excited about it because I researched about it, and I always wanted to relate engineering and the medical field together, and to actually find that was very exciting for me, so I'm actually ready for college.
I want to major in biomedical engineering because I am an athlete, and so I love sports, and I want to be able to combine the medical field with my engineering skills. Seems as though I am in the engineering department.
I want to be a computer software engineer, and I like computer software engineering because it binds computer software with games, and it gives you a way to express yourself through technology.
I'm not exactly sure where I want to go, but I do want to go into neuroscience or cognitive research.
When I graduate, I would like to go into the neuroscience field.
I would like to go to LSU and pursue a major in civil engineering.
I plan to attend ULL in the fall and do a double major in mechanical engineering and business.
I would like to go to Texas A&M, and I would like to study both mechanical and electrical engineering.
I want to go to Full Sail, and I want to go into the animation and movie business.
I don't know where I want to go to school, but I want to study electrical engineering.
I don't know where I want to go to school yet, but I want to do mechanical engineering.